Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have x sine inverse of x the whole divided by square root of 1 minus x square. So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down our y. So that's my y integral of x sine inverse of x dx the whole divided by square root of 1 minus x square. I know that my y is not in a very simple format whose antiderivative I know from first principles. But I do notice that I have three expressions within the integral, right? I have an x, I have a sine inverse of x, and I have a dx by square root of 1 minus x square, right? I don't think I even have this in the regular integral of u dv format basis which we've been solving problems so far. But then can I simplify my y, right, to bring it to that format? The answer is yes, because I know that I can connect my sine inverse of x with dx by square root of 1 minus x square, right? And how do we do that? By making a simple substitution, right? What is that substitution? T equals sine inverse of x, right? And when I do t equals sine inverse of x, I know that my x becomes equal to sine of t, and then my dt equals dx by square root of 1 minus x square, right? This is where it becomes very important for all of us to remember the derivatives from first principles, right? Because the moment you look at this particular problem, I want you folks to draw a parallel to d by dx of sine inverse of x equal to 1 by square root of 1 minus x square and connect these two with the substitution and make the expression much simpler than what it is, right? So now I go back to my y and I'm going to try and simplify this, right? With the substitutions what I've made. So I know that the substitution that I've made is t equals sine inverse of x, right? So I write my t as it is in place of sine inverse of x. Then I have an x, and in place of that I have sine t, because when my t equals sine inverse of x, my x equals sine t. And then I have my dx by square root of 1 minus x square equals dt, right? So this is what I have, right? Now you see, with a simple substitution, we have brought this to the form integral of u dv, right? Now it becomes a lot more simpler, and I'm not going to teach you how to solve this. My u equals t and my dv equals sine t dt, which means my du equals dt and my v equals minus cos of t, right? So we have my u, we have my dv, we have our du, and we have our v, right? And I know that my integral of t sine t dt is solvable using integral by parts identity, right? Integral of u dv equals uv minus integral of v du. I have my u, which is a t, I have my v, which is a minus cos t, and then I have my minus of my dv is sine t dt, and we arrived at v. We have a minus cos t, and therefore a minus into minus becomes plus. Because I remove the minus sign outside the integral, I have a cos t, and then I have my du, which is nothing but a dt, right? So this is what I have, and I know that this is not too difficult. Minus t cos t plus sine t, and then I have my constant, right? Now I'm going to go to the next line. We are not yet done. And why is that? Because I cannot leave my answer in terms of t. I will have to put back everything in the form of x, right? Now let's do that. Now what is my t? My t is nothing but sine inverse of x, right? So minus t becomes minus sine inverse of x. And then I have a cos t. So when my x equals sine t, what is my cos t? My cos t is root of 1 minus x square, right? There we are done with the first part of y. I go to the second part. I have a sine t, which is nothing but a x, and then I have my constant, right? So my answer to this problem is minus sine inverse of x times square root of 1 minus x square plus x plus c, right? There we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.